Hi everyone, good evening. Um, my name is Moses Afolayan. I'll be taking us in a very interesting journey to understanding the basics of statistical methods, hypothesis testing, and inferential statistics. All right, I'd like to thank Paul Adiroju for the privilege, who he's the course administrator for the privilege to take us on understanding this subject. All right. So I apologize once again as we ought to have taken this tutorial earlier during the day, later during the day around 8 p.m. But I was trying to get access to network, but I was entirely disappointed. But yeah, let's dive right into it. Let's go in for a trade. Okay. So yeah, I'll be taking this on this table of content. Yeah, I really believe that at the end of this brief, you'd have a good grasp of what it involves to carry out statistical tests and what are the intricacies in it. All right, let's go. So yeah, I have to put this here because from my experience, I practically learned how to carry out data analysis from a very um, experiential point where I did not know anything. That all I know now, in terms of an organized knowledge formally in what statistics involved, came afterwards. I practically would just pick up, spreadsheets, data sets, and just mess around with it, and just two things, just explore and also got opportunities to work with some people with zero knowledge. I mean, I knew nothing about statistics. Funny enough, statistics was my worst topic in math in secondary school, but now it's almost everything I do. I mean, there is no day that I don't involve myself with statistics. Yeah. So basically, you have to get yourself around the basics. The basics are very important. All right, you would always have to come back to the basics. You would never escape them because like we would say in the field of medicine, that common things occur commonly. All right, so you love to know those very common things, and don't first of all seek for the highfalutin concepts. Just take your time and let's go through the basics. All right. So yeah. So what is involved in statistics? Statistics is what provides us the plot, okay, the script. All right. So what you basically want to do with statistics is to make up a good story and tell it well. All right. Yeah. So the first thing you need to know when it comes to the basics of statistics, all right, is the different kinds of variables that we have. So what do variables mean? What do we mean by variables? Variables means how data present themselves. How do for example now, if you take an organized data set, for example, in an Excel spreadsheet, they are organized. You have a spreadsheet filled up with, let's say, names, people's age, their states, their country, their average income, their socioeconomic, basically the socioeconomic diversities. All right, you on just one Excel sheet, you must be able to identify what kind of variable you are looking at. Now, what does variable simply means? Variable simply means um, a unique identifier. I mean, so for example, in this class, let's assume we are 10 in this class, for example. Just being in this class, we can generate a structured variable set where I can say that from this, I might want to know the ages, the different age in this class, or I might want to know the different ethnic groups in this class. I might want to know the different career choices in this class. Now, all those words, those words I'm looking out for: the age, socioeconomic status, ethnicity, career choice. That terminology is a variable. All right. So that variable now dictates the kind of data that comes with it. Okay. So now let's one. So there are different kinds of variables, and it is good for us to have a very clear cut understanding of how variables present themselves, because everything you're going to be doing in statistics requires that you understand how variables behave. All right. Now see variables as matter. All right. They exist in different forms. They change forms based on how you want them to present. For example, water can exist as a liquid, can exist in a gaseous state, can exist in solid in the form of ice, can exist as crystals, can exist in different forms basically. All right, so you need to understand the fluidness, how fluid data sets are, and what I'm going to show us as we go on. All right. Um, Ideally, I would have asked us to take a deep breath just before we go on. Yeah, but this is pre-recorded, so let's move. Okay, so here we have different types and different kinds of data. Sorry, variables. Okay, so let me take us one after the other. And why this is important is because you need to be able to define what kind of variable am I dealing with. All right, so understanding this is very fundamental. It's king in the kind of analysis you're going to perform on different variable sets. Now, um, as we've seen here, I helped us categorize the different types of data set that we have. Okay, it's very haphazard. That means I try to define as many as possible. But guys, let's simply define it in two umbrellas. All right, the first one is a discrete or a continuous variable under quantitative type of a variable. Now, so basically, as the name implies, quantitative, what you can count. So it involves numbers, things that are measurable. All right. So under a quantitative type of variable, we have a discrete variable and a continuous variable. Now, what is a discrete variable? A discrete variable, discrete variables are you can refer to them as finite variable. That means they um, they have a definite okay, so we can call them integers in this point. You would easily want to give a particular number, a particular figure, or give a particular quantity to the age of a person, for example. All right, so they are finite. My age, I'm 22. My age, I'm 35. My age, I'm 24. Those are, finite counts. Now, infinite numericals, which involves the continuous variables, temperatures, um, distance, right? Time. They are infinite. That means you can explore them to an infinite, you know, infinite extent. All right. So qualitative, which you would use a whole lot. Now, okay, so let's go back to quantitative variables. How can quantitative variable present? Okay, um, why are they important? Because, for example, I want to sell. So I involve myself in a number of research. Now, imagine they want to sell OCPs. Now, OCPs are what we call the contraceptives, all right, for prevention of pregnancies, like emergency contraceptives, ECs. Okay, I want to sell it to a population or in a country or in a state. I, I as a business person, I would like to simply know what is the age distribution in this particular community. All right, because I want to find out, is this community valuable for my product? Will I would it be what's the significance of the age for my product? All right, we know that those who regularly or ideally use emergency contraceptives are those within the teenage age group. Let's say people from 16 um, to, let's say, people from like 25. All right, so that although that exceeds the teenagehood, but just above or just close to the adulthood, and all right, so that age group is important to me. So let's assume I take the data set of, let's say, like 100,000 people, and I have different ages. I have 14, 15, 16 everywhere, and all of that. That data set does not make, I have to transform that data into another form that makes more sense. Let's say mean, for example. I want to find out what's the average age group. Now, the mean tells me the concentration. That means most. So let's say I take the mean of that population, and you find out that the mean population is between the ages of 17 and 19. All right, that means what that means is that the concentration of that population falls within that range. Okay, now so I have taken that age away from being a single number or sets of single number to a range. Are you with me? So I've taken that water into a gaseous form. Okay, so now that takes us to qualitative variables. So it's not static. All right, it's a fluid. It has a fluid feel to it. A qualitative or a continuous or a discrete variable can be manipulated, or is that the right word, can be transformed, thank you, into a qualitative variable. Now, qualitative variable are very interesting. They are very beautiful because you interact with them on a very regular basis. Now, qualitative variables, like I said, they are what? They are categorical. So that means they are in groups. Now, nominal variables. These are categories of variables you can have. It's they have their unique identifier also. All right, for example, things like gender, male, female. Well, in the western world, they tell us gender is fluid. I don't know how true that is, but okay. So we also have nationality, eye color. All right. um yeah, now we can also have, let's say, educational levels. Now those are ordinal variables. That means they're in order. That means they have like a step wedge format to them. 100 level, 200 level. So there are different class to it. Okay. Dichotomous variable. That means variables that appears in two different forms, either yes or no, true or false, up or down, left, right. All right. Intervals, intervals. Now, why is interval important? Interval is important because it's specific for figures. All right, just like I just described that I've collected the age of 100,000 people in a population, and I've transformed it into a range. In statistics, we call that range an interval. So I can say I want to classify those 100,000 people, those ages, into four categories. I can say those who fall between the ages of 14 and 20, those who fall between the ages of 21 to 34, those who fall between, that interval. All right. So that's the fluidity between that example and this. All right. Ratios also. Although ratios do not really occur commonly in what we do, but yeah, it's good to pay attention to it. All right. So yeah, this slide just basically give a more elaborate explanation on what I've explained earlier. Okay. Oops. So yeah, why did I say oops? Because this shouldn't come now. I just wanted you to scare us a bit. But no, don't be scared. Now, why shouldn't we be scared? It's because you need to understand distribution. Now, this is where we we look at Um, okay, so I spoke about um, taking the age of a 100,000 population. All right. So I haven't collected that data before you progress, or before you make another effort into analyzing that data. Okay, you need to understand how is this data distributed. Now that will take us to the next slide. So in the process of reaching an hypothesis, in the process of testing an hypothesis, before you get there, you need to first of all understand distribution. So we would easily tell ourselves, is this data normally distributed, which we would use a particular term called parametric or non-parametric. So pay attention here that this word normal simply means parametric a parametric data set, and the other ones will classify them as non-parametric. Okay, guys, don't worry, don't be lost. We're on the same boat. I'm going to get everybody on the safe harbor very soon. All of this will make sense at the end. All right. So normal distribution. Okay. So why is it important? It's important because it determines the type of test you can carry out. Okay. Now, why is that important? Because I just picked 100,000 people from a country. That 100,000 people does not represent the 200 million people in that country. For example, Nigeria. Okay, so I'm taking a portion from a whole. Let's take for example a um, meat pie. Now, I mean of us, I'm sure many of us take meat pie. I do a lot. And if you notice, there's a way you take your meat pie that at the beginning there's this hard surface. All right. So, but as you keep chewing, as you keep biting, the content changes. Usually at the center, you get all the goodies. Then it's as though you are now sad when you're finishing up the meat pie. Why? Because the other end is also hard. Do you get it? So in your mind, what does that tell you? It looks like a curve that is stepping up, from the hard part, which is of low level of satisfaction to you, and to the upper part, which is of higher satisfaction, and then it does, is an anticlimax. Now, that kind of shape is what we call a bell-shaped curve. All right, it shows a normal distribution. Now, how can you get a bell-shaped curve? Usually we get a bell-shaped curve by plotting an histogram. All right. Yeah. So an histogram is basically, I'm sure many of us know what histogram is or what histograms are. Basically, bar charts that are clustered around to show us distribution. So whenever you look at your data, whatever software you're using, you can simply ask that software to give you the shape of that data. So it's going to tell you. So usually we use that we check for normality of distribution um, with continuous variables. All right, with continuous variables. Yeah, you can pause this video at this point, write down those questions and send them to me. All right. See, but yeah, let's go on. Now, another thing again, apart from mean, I give an example of mean when calling for age. I also give an example of interval. Another important finding you want to do is a standard deviation, for example. Okay, a standard deviation. A standard deviation simply tell you how your data fall negative within the negative side and the positive side. We'll talk about that later. Now, another thing again, another thing again that distribution tells you. So let's assume that your data is normally distributed. It means that your mean is of essence. Your mean is very valid. It means your mean is of essence when you're. That means you can rely on that mean. It means that what you have at the center of that meat pie, okay, is actually what the seller wants you to taste. Do you understand? So you can rely on that middle part. Okay. So what if? The mid pi is not, sorry, I'm using mid pi. So what if the data set is non-parametric? That means it is not normally distributed. You would rely on the median. You right? You rely on the median. The median means, okay, we are taking one singular set that is in the middle. Okay, now that would come into play, and I'll show you why that is important. Okay, let's go. All right, so this is a pathway to, reaching the end goal. Usually the end goal is inferentials. So yeah, so what do you start with? Like I said, you first of all determine the kind of data sets you are working with. Am I dealing with what kind of variables am I working with? Continuous variables, discrete variables, categorical variables, variables in intervals, variables in ratios. All right, you determine that. You can go ahead and calculate your mean after you've done a normality check. Let me put this in. There are some other statistical tests that we can use to check for normality. One of those tests is what we call chemograph. Okay, don't worry, I'll type it and I'll send us the material. So the test for normality, I'll send that to us very shortly. So the first one, like I said, you can use histograms. Um, just for visual representation to check for a visual inspection. Another test, we can use what we call Shapiro-Wilks test. So the purpose is also to check for if a data is normally distributed. All right. Shapiro-Wilks test. Also, we can use Komogrov Smirnov's test. I'll send that document to us. Also, we can use an Anderson-Darling test, which is used also to compare. Although this Anderson-Darling test is a more powerful normality checking test than Komogrov Smirov. All right, sorry, I'm Nigerian. Also, we can use skewness and kurtosis. Skewness and kurtosis simply means when you run a skewness test. So usually a skewness value that is near zero suggests to you that the data is normally distributed. Okay, and that means a positive skewness indicates a distribution with a normal distribution, and a negative one means that the data is skewed to the left, and the positive one means the data is skewed to the right. Okay, all right. Kurtosis. So kurtosis basically um, it shows that it's there's something we call tails and heads, but I'll save us those jargons for now. I believe those ones I've mentioned are enough for us to check for a normal distribution. So after checking the normality of distribution, if it is normally distributed, you go with the mean. You stick with the mean. If it is not normally distributed, you go with the median. So if you choose to go with the mean, which often that's what we go for in a normally distributed data, then you go ahead and calculate your standard deviation, and then you move on with your statistics. So this is the schema. All right. So what do I mean by the marrow? Those of us who are medical students understand that marrow is where every other thing is formed from. It is in the marrow that we have the what other the marrow is what evolves, all right, into other things. So once you can understand these basics, I call it the basics, but here I call it the marrow. Once you have a good idea of what this basics is, I can tell you you are good to go to pick up any kind of data set in the world. I mean, in the world, I've done analysis for some bank or some marketing organizations, some finance companies, even as a medical personnel. Why? Because I understand these basics. Okay, I've worked for international health organizations, and I'm not scared. Okay, because I know whenever I get the data, I have these basics behind on my fingertips. All right. So basically, a descriptive data set. Okay. Now we're going into the performance stage. Um, in the descriptives, you have the things I just mentioned earlier. All right, the mean, the median, the mode, the standard deviation, percentages, the variance. Okay, now why do we have these things? Why are they important? Why are descriptive statistics important? Okay, now as a data analyst, you need to understand the significance of each of these approach. For example, someone can tell you that um, that 90% of Nigerian youths, okay, are unemployed. Wow, that's very glaring. 90%. Now the next question that should come to your mind is 90% of what? Now why? Because the person probably must have just randomly selected 10 Nigerians, 10 Nigerian youths, okay, and asked if they were employed or not. Now guys, 10 out of 10 out of I'm assuming, let's say, because according to World Health Organization, we have Nigeria is about 65 to 70% of youths. All right, so let's say, amongst 140 million youths in Nigeria, you're telling me you only selected 10 and you give a percentage to it. So, with that kind of data set, with that kind of sample size, telling me 90% is a false positive. Okay, it's a truthful lie. Why? It's not representative of the whole population. Okay, so you need to understand, what role does percentage play, what role does standard deviation play, what role does median and mean, what role do they play? Is that all right? So also you need to know when to carry out what kind of descriptive statistics. All right. So we'll jump right back to descriptives, but let me give us an overview of each of these, rudiments. So the inferential, so distributions. All right. Talked about distributions, either parametric or non-parametric. Okay. Then now, my favorite, inferentials. Inferentials. Okay. So before we go to inferentials, let's look at hypothesis testing. What does hypothesis testing mean? Now, understand that as a data analyst, you're going to be working with research units. That means you are there to provide insight. I mean, you're there to provide facts and figures. Okay, so what do you do before you go ahead to explore that data? You already have an assumption. You have something you're assuming in your mind. I think, for example, a recent study we just conducted, we wanted to find out, because I'm part of this organization who they want to improve the uptake or the willingness of people to um to take the HPV vaccination. That's the human papillomavirus vaccination, which can prevent people from coming down, which should prevent people from coming down with cervical cancers. All right, so we have an assumption that the reason why the uptake is poor in a country like Nigeria, for example, is that people are not aware. People do not have a good knowledge, a viable knowledge about the vaccine. So we have an assumption that there is a significant relationship, but there's an association between the level of knowledge of that population and their uptake of that vaccine. Now, what I just said now is an what we call an alternate hypothesis. That means I'm saying that there's a positive relationship between those domains, the domain of the knowledge and the domain of uptake of that vaccine. Now, a null hypothesis means there is no association. All right. So I'm assuming that there is no relationship between a person's ethnic group, okay, and their choice of a political candidate. All right. So before I pick up that data set to analyze it, I already have an assumption. Okay, I think this is what should be. So you are going into analysis either, okay, to accept or to reject an hypothesis. Okay, so guys, if I reject a null hypothesis, that means if I reject the notion that there is no association, all right, if I reject the assumption that there is no association, it automatically means I have accepted the alternate hypothesis. So two things, you are either accepting a null hypothesis or you are either rejecting it. So if you reject the null hypothesis, it simply means you're accepting it. Sorry, you're accepting the alternate hypothesis. All right, other things you need to pay attention to when I'm talking about hypothesis testing is the p-value. All right, guys, so we'll take a break here. We'll continue in the next video. Yeah.